Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 66. Determine the polar moment of inertia of the area shown with respect to part A, point O, and part B, the centroid of the area. So here's the given figure. So it's just two triangles and symmetrically positioned with respect to the horizontal and the vertical through the centroid. So we'll call the horizontal axis through the base as the x-axis and through the point O as the y-axis. So IO is equal to IX plus IY, and Ix is equal to moment of inertia with respect to the base of big triangle minus moment of inertia of small triangle with respect to the base, which is the formula in general, it's BH cubed over 12. So Ix is base 160, 160, 40, 40, 40, 40, 160 times 80 cubed over 12 minus 80 times 60 cubed over 12. So Ix is 160, 80 cubed over 12 minus 80 times 60 cubed over 12. So Ix is equal to 5.3867 times 10 to the 6 millimeter to the fourth. Then Iy, this is the y-axis, and this coincides with the height of the triangle with base 80 and height 80 also, and we subtract the moment of inertia of the triangle with respect to the height, which coincides with the height also, which is with base 40 and height 60. And we multiply the moment of inertia by 2 because to the left of the y-axis, we have identical triangles. So Iy is equal to 2 times quantity base cube 80 cube times 80 cube over 12 minus 40 cube times 60 cube over 12. So Iy is equal to 6.1867 times 10 to the 6 millimeter to the fourth. From here, we can now solve IO, Ix plus Iy. So 5.3867 plus 6.1867 times 10 to the 6 is equal to 11.57 times 10 to the 6 millimeter to the fourth. So with respect to the centroid, which is somewhere here, distance from the x-axis is denoted by yg, and the area of big triangle is 1/2 of 160 times 80. So ig is igx plus igy, by the way. So area is 1/2 of 160 times 80 minus 1/2 of 80 times 60. Area, big triangle is 6,400, small triangle 2,400. So the area is 4,000 millimeters square. By Varignon's theorem, 4,000, the centroid of the big triangle from the x-axis is 1/3 of 80. So 4,000 yg equals 6,400 times 80 over 3 minus 2,400 times 1/3 of 60, which is 20. So yg is equal to 92 over 3 mm. So we transfer the moment of inertia of each triangle with respect to the centroidal x-axis of the entire area, and that is moment of inertia of individual triangle with respect to the centroid, base height cube over 36 plus area times distance squared. The distance is the difference in the centroidal y-axis of the individual area and yg. So IGX is equal to 160 times 80 cube over 36 plus 6,400 times 92 over 3 minus 80 over 3 quantity square, where 92 over 3 is YG and 80 over 3 is the centroid of the big triangle, which is 80 over 3, that one. Then plus a minus, sorry, for the small triangle, 80, 60 cube over 36, then minus plus 2400 times quantity 92 over 3 minus 20, where 20 is the centroid of this small triangle with respect location of the centroid from the base, quantity square. So computing IGX is 2.3780 times 10 to the 6 minus for this quantity here 7.5307 times 10 to the 5. Combining IGX is equal to 1.6249 times 10 to the 6 millimeter to the fourth. IGY on the other hand happens to be the IY also because the centroid passes through the y-axis. So IGY is the same as 6.1867 times 10 to the 6. So IG is quantity 2.37, 1.6249, then plus 6.1867 times 10 to the 6. So IG is equal to 7.812 times 10 to the 6. Level 67, determine the moment of inertia with respect to the centroidal x-axis for the triangular region shown. So for our solution, let's have two ways to solve this. One is using Ix equals I bar x plus area bar yg square. The other, and the calculation of the area is area by coordinates. The other solution is we transfer its areas, that moment of inertia of each areas to the centroidal x-axis of the entire areas. And we solve for the area by simply 1/2 base times height for triangle and base times height for the uh, rectangle. So imagine we have a trapezoid here, this trapezoid. Then we divide the trapezoid into two parts, this triangle and this rectangle. Then we subtract the area of this triangle and that triangle there. So in that manner. So this is 6, this is 7.5. So that's the location of the centroid. The centroid of this triangle here is from the x-axis is 1/3 of 7.5, so 2.5, 3 plus 4.5 is 7.5. The centroid of the rectangle is 7.5 over 2. The centroid of this triangle is 1/3 of 3, so 1. The centroid of this triangle is 3 inches plus 2/3 of 4.5, which is also 3, so 6. So that's YG. The area here of this triangle is 1/2 of 6 times 4.5. And the centroid there is, as I said, 6 inches from the x-axis. So for our guide formula, Ix equals I bar x plus area yg square. So for the area by coordinates, by the way, Ix is for this triangle 6 times 7.5 cube over 12. BH cube over 12. So 6, 7.5 cube over 12 with respect to the base or the x-axis for this triangle here. Then for this triangle, base is 6. For this rectangle, rather, base is 6, height is 7.5. So 6, 7.5 cube over 3. So plus 6, 7.5 cube over 3. For this triangle here, with respect to the x-axis, which is the base is 12, height is 3, so 12, 3 cube over 12. So minus 12, 3 cube over 12. Then for this triangle here, we need to transfer because this is the centroidal axis and it is at distance 6 from the x-axis. So minus quantity base is 6, height 4.5, quantity cube over 36 plus area 13.5, distance 6 square. So computing, Ix is equal to 526.5 inches to the fourth. Then the area by then YG is 1/3 of the Y coordinate. So Y coordinate here is 0. Here it's 3. And here it's 7.5. 7.5, the Y coordinate here. So YG is equal to 1/3 of the quantity 0 plus 3 plus 7.5. So YG is 3.5 inches. So having found that, then we can compute the area by coordinates also. So 0, 0 area is 1/2 of 0, 0. By the way, this is 18 square inches. The area here is 1/2 of 12 times 3, so 18 square inches. So area is 1/2 of quantity 0, 0. This is 12, comma 3. Coordinates, this is 6, comma 7.5. Then back to 0, 0 to close the figure. Then area by coordinates is 1/2 of quantity 0 times 3, 0, plus 12 times 7.5, 90, plus 6 times 0, 0, minus quantity 0 times 12, 0, plus 3 times 6, 18, plus 7.5 times 0, which is also 0. Area therefore is 90 minus 18, 72 divided by 2. So 36 square inches. By the way, the rule in analytic geometry is we have to arrange the coordinates in counterclockwise manner to ensure that the area is positive. So remember, counterclockwise rotation is always positive. Do not think that clockwise is positive. Even in trigonometry, the counterclockwise rotation of angle from the positive x-axis is the positive direction of angle. So next, we apply Varignon's theorem 526 point, sorry, Ix is 526.5 equals I bar x into this equation. Then area 36 YG is 3.5 square. So I bar x is equal to IGX equals 85.5 inches to the fourth. For our second solution, we need to uh, transfer its centroidal moment of inertia to the x-axis. So area is 1/2 of 6 times 7.5 plus area of rectangle 6 times 7.5 to prove that YG is 3.5. And we solve area by coordinates here. Then minus this area of this triangle 13.5 minus the area of this triangle 18. So area is 22.5 plus 45 minus 18 minus 13.5, which is 36 square inches also. So which proves this area here by coordinates. Then 36 times YG equals area of this triangle 22.5. The location of centroid from the x-axis is 1/3 of 7.5. That's why it's 2.5. Plus area of this rectangle, which is 45, that one. Then the location of centroid from the x-axis is 1/2 of 7.5. Then minus 18. Then the location of the centroid of this triangle from the x-axis is 1/3 of 3, which is 1. Then minus 13.5, this triangle here, the distance of its centroid from the x-axis is 6, which is already calculated and labeled as shown. So YG is really 3.5 inches. Then by transfer formula for this triangle 1 here, so I bar x rather, we directly transfer it here. So I bar x is base 6 times 7.5 cube over 36 plus area 22.5, then distance YG 3.5 minus 2.5, that one, location of its centroid from the x-axis. So the vertical distance, this vertical distance is therefore YG 3.5 minus 2.5 quantity square. Then for the rectangle, base is 6, height is 7.5 cube over 12 plus area 45, distance 7.5 over 2 minus yg 3.5 quantity square. Then minus for this triangle here, base is 12, height is 3 cube over 36 plus area 18, distance yg minus 1 because 1/3 of 3 is 1, that one, quantity square. Then minus for this triangle, base is 6, height 4.5 cube over 36 plus area 13.5, distance 6 inches minus yg 3.5 quantity square. So computing individually, I bar x is equal to 1485 over 16 plus 855 over 4 minus this 243 over 2 minus this brackets value 1593 over 16. Combining I bar x is 80, IGX equals 85.5 inches to the fourth. Level 68, approximate the moment of inertia about the x-axis of the semicircular area by dividing into 5 horizontal strips of equal width. Treat the moment of inertia of each strip as its area width times length if its horizontal midline width times length of its horizontal midline times the square of the distance from its midline to the x-axis. So area uh, distance square. Compare your result with the exact value. So it is a semicircle. In general, the length of midline, we'll call that B1, our solution, and the distance of its midline, which is also supposedly the approximate location of the centroid of this rectangular strip from the x-axis, is in general 8 sub m as shown. So that's B1 and 8 sub m as shown. Since moment of inertia is distance square times area, the area is 2 times B1 because this is also B1 times 1 inch, the thickness. So Ix approximate is equal to summation of HM squared, distance squared, times area of the strip, which is length 2B1 times thickness 1 inch in general. So Ix approximate is 2 times summation of HM square, where B1 is square root of radius 5 square minus HM square. By the way, HM is zero point 0.5. Then the midline is here 1.5, the midline is here 2.5, the midline is here is 3.5, and the last midline is 4.5. So HM varies from zero point 0.5 to 4.5, and it increases by 1 inch. So I approximate is summation of 0.2 times 0.5 square, square root of 5 square minus zero point 0.5 square. That's for this area here. And the imaginary midline is this one. 2 times square root of 5 square minus zero point 0.5 square. Then plus for this rectangle here, plus 2 times HM is 1.5 square, square root of 5 square minus 1.5 square. For this midline here, for this rectangle here, the approximate moment of inertia is 2 times 2.5 square, then square root of 5 square minus 2.5 square. For this fourth rectangle, so plus 2 times 3.5 square, square root of 5 square minus 3.5 square. And for the last rectangle, imaginary rectangle, 2 times 4.5 square times square root of 5 square minus 4.5 square. So computing individually, Ix approximate is equal to 2.4875. That's the first. The second is 21.464. The third is 54.127. The fourth is 87.4825. And the last is 88.268. Combining, Ix approximate is equal to 253.8 inches to the fourth. The exact value is moment of inertia with respect to the x-axis of a semicircle, which is pi r4 over 8. So pi over 4 times 5 to the 8. That's the exact value. Pi over 8 times radius to the fourth. So pi times 5 to the fourth over 8, and that is 245.4 inches to the fourth. Level 69, determine the minimum moment of inertia of the region with respect to the x-axis. So here is the given figure. So the requirement is to minimize the moment of inertia with respect to the x-axis, and the variable here is this h here. So we treat the areas as rectangle with respect to the base, and these two rectangles with respect to the base, and the formula is base height cube over 3, and it is equal to 4. This is 4 minus h quantity cube over 3 plus 2 times 1 h cube over 3, because it is with respect to the base. So for our solution, Ix is equal to 4 times 4 minus h cube over 3 plus 2 times 1 h cube over 3. Simplifying, Ix equals 4 thirds of 4 minus h cube plus 2 thirds of h cube. Then differentiating with respect to x, differential of Ix with respect to h is 4 thirds times 3 quantity 4 minus h squared times derivative of 4 minus h negative 1 plus 2 thirds 3h squared equals 0. So simplifying, we have 2, by the way, 3 over 3 is 1. So 2h squared here. Then transpose this to the right. So that becomes 4 times 4 minus h quantity squared. So cancel 2. So this is 2 h squared, then expand h squared is 2 times quantity 16 minus 8h plus h squared. Since 2h squared is 2h squared minus h squared is h squared, so 0 equals h squared minus 16h plus 32. So 2 times negative 8, negative 16h, 2 times 16, 32 equals 0. Then using the calculator to solve for the roots, h is 8 plus 4 square root of 2 feet, which is absorbed because it is greater than 4 feet. So the other value is h. H is 8 minus 4 square root of 2. So this is the acceptable and with sense value. So 8 minus 4 square root of 2 is approximately 2.343 feet. So substitute here the value of h, and that corresponds to the minimum moment of inertia with respect to the x-axis. So Ix minimum is 4 thirds of 4 minus quantity 8 minus 4 square root of 2 cube plus 2 thirds of 8 minus 4 square root of 2. So this is the value of h quantity cube. So Ix minimum is equal to 14.64 feet to the fourth.